Hey guys, this video is for page 38 of your interactive notebook about balancing chemical equations. You might remember a little bit about balancing chemical equations from 8th grade, which is probably when you first learned it. So if you'll recall, we balance chemical equations in order to satisfy the law of conservation of matter. And the law of conservation of matter states that matter cannot be created or destroyed, although we can definitely change the form that matter comes in. However, any atom that goes into a chemical reaction is going to come out of a chemical reaction also. So if I have an atom of carbon go in, I can't destroy that atom of carbon, although I can change its form. It might come out in a different compound. Likewise, I can't create matter. So if none of my reactants include hydrogen, then I can't have a product that includes hydrogen. So because of the law of conservation of matter, chemical reactions must be balanced, meaning that all of the elements found on the reactant side must also appear on the product side, and, more importantly, occur in the same numbers. So in order to balance a chemical equation, we're going to add coefficients. Coefficients are numbers that we can put in front, and you will multiply the number of each element in the compound by the value of the coefficient. It is important, though, that you never change the subscripts. So remember, the subscripts of a chemical formula tell us how many atoms of each element are within a compound, and we can't change that. That is set. So we are never going to adjust subscripts to balance. We're always going to use coefficients. All right, so let's talk about some steps to balancing chemical equations. The first thing that we're going to do is count the number of atoms of each element on each side. So we're going to look at an example here on the left of C2H4 combining with O2 to produce CO2 and H2O. Now, if you've already recognized that this is a combustion reaction, that is good. You should have. And so that's why we have a hydrocarbon plus O2 producing CO2 and H2O. We're going to count all of the atoms on each side. I have 2 atoms of carbon because in C2H4 there are 2 atoms and there's no carbon elsewhere in the compound. On the right side I only have 1 atom of carbon in CO2. Hydrogen, there are 4 on the left and there are 2 on the right. Oxygen, there are 2 on the left. On the right there are 3, 2 in CO2 and 1 in H2O. That's 3 total. Step 2 is to balance each element one at a time by adding coefficients. And we will start with elements that are only in one compound on each side, and then generally leave hydrogen and oxygen for the end for no other reason than because they usually will occur in more than one compound, and we want to keep this as simple as possible. So on the left, if we're balancing this equation, C2H4 plus O2, we're going to start with carbon because my only other atoms are oxygen and hydrogen, and our rule says that we want to leave those for last. So we'll start with carbon, and I balance that by adding a 2 in front of CO2, so that now I have 2 atoms of carbon on the left and 2 atoms of carbon on the right. Remember that we multiply the number of atoms by the coefficient. So because there's only 1 atom of carbon in CO2, but we have 2 of them, our total number of atoms of carbon is 2. Back to the right, the third step is that after we add a coefficient to a compound, we need to recount all of the elements again, as we might have changed numbers of other elements. So back on the left, now that we've added this 2, we need to recalculate how many atoms of hydrogen. 4 on the left and 2 on the right. That didn't actually change because hydrogen only occurs in H2O in this example, and we didn't add a coefficient to that. However, when we look at oxygen, we have 2 on the left. That didn't change, but we did change the number of atoms of oxygen on the right because there is oxygen in CO2. So now instead of only having 3 atoms of oxygen on the right, we have 2 times 2 is 4 plus 1, that's 5 atoms of oxygen. Step 4 says continue adding coefficients and balancing until each element is balanced on both sides of the equation, and don't forget to recount all of your elements in between. So we'll finish up this example. We're going to choose to balance hydrogen next. we have hydrogen and oxygen left, but notice that oxygen is in multiple compounds. It's in CO2 and H2O, and that's going to complicate it if we try to balance it before hydrogen. So we're going to balance hydrogen first, since it appears only in one compound on the left and one compound on the right. So we had 2 atoms of hydrogen on the right and 4 on the left, so we're going to stick a coefficient of 2 in front of water here. And then recount everything. That's 2 atoms of carbon on the left, 2 atoms of carbon on the right. 4 atoms of hydrogen on the left, 2 times 2 is 4 atoms of hydrogen on the right. 2 atoms of oxygen on the left, and now we have 2 times 2 is 4 atoms of oxygen, plus 2 times 1 is 2, so plus 2 is 6. So 6 atoms of oxygen on the right. So while carbon and hydrogen are balanced, we're not quite done. We still need to balance oxygen, so that's what we're going to do last. Because we need 3 times as much oxygen on the left as we have in order to balance it with the oxygen that we have on the right, and the compound on the left is O2, we're going to put a coefficient of 3 here, and then recount everything one more time. That gives us 2 atoms of carbon on the left and 2 on the right, 4 atoms of hydrogen on the left and 4 on the right, 6 atoms of oxygen on the left, that's 3 times 2 is 6, and then 6 on the right. Remember, 2 times 2 is 4, plus 2 times 1 is 2, that's 6 total. At this point, there's equal numbers of each element on the left and the right. You'll notice all of these are the same, so our final balanced chemical equation is C2H4 plus 3O2 yields 2CO2 plus 2H2O. It's very important that you practice this skill. Your success in the next unit was going to depend heavily on your ability to balance equations. So to that end, there's a practice worksheet that reviews both types of reactions and writing and predicting products, and also balancing. Also, if you head to the website, you'll find a link to another website that has a place where you can practice examples of balancing and also check your answers. And that's it for page 38 on balancing chemical equations.